two numbers have a difference of 3, what is the minimum product that those numbers can have? Okay, so before we get into the function, let's just try out some numbers here and see how this thing behaves. If two numbers have a difference of 3, they could, for example, be 10 and 13. And the product of those two numbers is 10 times 13, which is 130. If I cut the numbers down a little bit, if I do, say, 8 and 11, the product of those numbers is 88. If I do, I don't know, 5 and 8, the product of those numbers is 40. So the product isn't always the same, and in fact, right now the product of these numbers is dropping. And if I go to, say, 0 times 3, the product of those two numbers is 0. So the product drops, and it keeps on dropping. Does it keep doing that forever? What if I have like minus 10 and minus 7? Well, now the product is 70, so the product was dropping for a while, but then it rebounded and started coming back up. We had 130, 88, 40, 0, and then back up to 70. Somewhere in here, there must be a minimum. There must be a place where this thing turned around or where it bottomed out. And that's what we're supposed to find, the minimum product. The way you attack a problem like this is if you can get an equation for this curve, and if you can find its derivative, well, the derivative of a curve is its slope. And on this curve, if you find that the slope is negative, it means you're on this part here where the line's coming down. A positive slope would mean you're on this side where, as you increase x, the numbers are going up. And a slope of 0 right here, that's the magic value. If the derivative is 0, it means the curve is flattened out. And so a 0 derivative means you're standing at the bottom of a valley, or in some questions it'll mean you're standing on the top of a hill, which is also good to know. It means, in this case, it means you've maximized something. In this case, it means you've minimized something. And in general, we call these optimization problems, which means finding the best or the most value. So let's see if we can do this using some of our trusty algebra. If two numbers have a difference of 3, the generic way to say that is that one of the numbers is x and the other number is 3 more than that. Okay, so these numbers are always 3 apart. If you want to put x minus 3 here, go ahead. It'll come out the same way, or you'll get the same answers in the end. I like the plus. I'll avoid negative signs if I have a chance. So one of the numbers is x, the other one is 3 bigger than that. And the product of those numbers, which I will call p for product, is x times x plus 3. And there's no way I can leave that way. I can't resist expanding that. So there's our product. And you can see it is a parabola that opens up, so it does have the kind of shape that I doodled when we were doing our examples. It does look like something that should have a lowermost value, or what we'd call a vertex. Now there's ways to find a vertex using completing the square, but we have much better ways now because of calculus. We can find where the derivative of this, dy dx, equals 0, and here's how that goes. dp dx, sorry, here I was using dy dx, that's my general version, but here we're minimizing a product, so dp dx, same deal. And that derivative is 2x plus 3, and we want it to come out to exactly 0. So what x is it going to take to make that happen? Subtract 3 from each side, divide by 2. So if x is minus 3 over 2, that would mean the two numbers are minus 3 over 2 and minus 3 over 2 plus 3, which is plus 3 over 2. And if you multiply those, you get a product of minus 9 over 4, or minus 2.25. And that is the lowest product you can possibly get from two numbers that are 3 apart. Generally, you get positive values, but you can just barely get into the negatives and get this far down if you pick exactly the right points, or the right x values. And there you go.